Hi, welcome to Maximizing Your Machine Utilization with Automation. My name is David Walton. I'm Director of Engineering Operations here at Makino. And I want to let you know that after the session today, there will be a live Q&A question session that will be online in order to answer any questions that you may have after the presentation has been completed. So today we're going to be talking about a couple different topics. One is the elements that are required for a successful machine tending automation implementation within your shop. And the second one is going to talk a little bit about the different automation solutions and systems that are available when it comes to machine tending automation. So first of all, we're going to talk about the different elements that are essential for a successful implementation of machine tending automation. And when we talk about this, there's 6 different areas that we want to focus on, right? And so the first one that we're going to focus on will be the machining center. So now that you've invested this money, or you're going to invest money in an automation system that's going to be servicing your machining center, you want to make sure that that machining center is up and running and it continues to run reliable while your automation is running and servicing that machining center. And Makino, we've done a couple things in order to make our particular 1 series machines and our other product lines very amenable to be run in an automated system, an unattended automated system that's running in a 24/7 type of operation. One has to do with single piece way covers. So on the 1 series machines, our X and Z axis covers are single piece. And over the life of that machine, we've got a very low percentage of those way covers that have been changed and replaced over the life of the machining center. The next has to do with the tool chain system. So we want to make sure, since you'll be changing tools unattended day after day, 24 hours a day, you want to make sure that that mechanism can stand up to the rigors. We design our systems for 2.4 million tool changes per year. It's a simple cam-driven system. But one thing to note on our shutter door, as far as the access to the machine tool magazine, we've went from a pneumatically controlled door shutter door to a servo control, because with the pneumatic, we found out there was a little bit more issues, more preventive maintenance required with that. So now we've got a servo controlled shutter door that operates more reliably over the life of the machining center. And then the spindles. So Makino typically in 1 year will ship as a replacement spindle less than 4% of the installed base of those spindles that we have out in the field. So quite a low, small percentage number of replacement spindles that will be shipping within a year's time. And then the stability of the machine, because you want to have a stable process, and talk a little bit about that here in a minute, but you want to have a machine that is stable. So we've got the step bed and column design that adds rigidity to the machining center, which adds stability to your machining process. And then our active thermal management system. So what we want to do is we want to keep that machine thermally stable throughout the course of your production sequences, whether it's starting up first thing in the morning, or maybe when you're shutting down temporarily for shift breaks or lunch breaks or something of that nature. We want to make sure that you're producing consistent quality parts throughout the different time zones or the different activities that will be going on during your production schedule. Next, let's talk about the machining options. So you need to have options that help integrate your machining center with the machine tending automation. And where we like to start here is a robot interface. So you have to have communications between your automation system, whether it's a part-based system, robot, or some type of pallet automation, and the machining center. So at Makino here, we have developed some standard robot interface platforms based off the particular needs of the automation. A couple of features of our robot interface have to do with pallet and parts status tracking. So we want to know the status of the parts and the pallets that are in the machine. So when we load a part, we load a pallet in the machine, we know what part number that is, maybe what part type, what program we have to run. So that's all stuff that we want to make sure that we handle within the machining center. Fixture and chuck control. We'd like to have that done within the machining center, because it gives you as the customer and the operation of this automation, it gives you more flexibility in what you can do within the control of your process, within the control of the machining operation, if that machining center is actually doing the fixture and chuck control. part program selection, program start and stop. So from the robot, from the automation, maybe you want to input, this is a part number, this is the pallet number that's been loaded, and you want to control the stopping and starting of the machine via the automation. So we all provide those signals in order to make that happen. And then part inspection. So we want to be able to know, coming off that machine, did something happen during the course of that machining process that now you want to flag that part to go to a gauge stand, go to a CMM, or go someplace to be inspected. Then one of the reasons may be that you've used a tool for the first time. If you're using Spare Tool Select or the operator changed the tool sometime in the course of machining of that part, you want to know that because you want to make sure that feature is still within tolerance and that tool is set up properly. So the benefit is you've got a tightly integrated machine within your automation. So the automation and the machining center are talking together, exchanging the proper information required in order to have a smooth running operation. Let's talk about fixture control and the control of that fixture. Now that you don't have the operator, you're not manually loading those parts, you're not manually clamping those parts down. So you need to have some type of control within the machining center in order to control the clamping and unclamping of the fixture or the pallet chucks. So we've got both hydraulic and pneumatic control available. We've got our fixture unit, which connects to the fixture and provides that fixture control, as I mentioned, via hydraulics or air. Then part and pallet seat detection. So you want to make sure that that part is properly seated within the fixture, or that pallet is properly seated within the chuck, within the machine, in order to start your machining sequence. We also have machine pallet seat confirmation also within the machine to make sure that the machining pallet is properly clamped to the table prior to beginning the machining process. And then fixture cleaning options. So as you're changing those parts and you're changing the pallets in and out of the machine, it's a very dirty environment. You've got coolant, you've got chips flying all over the place. You need to make sure that you clean those out and that you don't have those on your locating surfaces when you're exchanging those parts or those pallets. So we've got the fixture wash through fixture coolant. We've got air coming up through the chucks in order to keep those surfaces clean, those mating surfaces clean throughout the process of exchanging the parts or the pallets. So the benefit there, once again, you're tightly integrated with the automation, so you're effectively able to support the exchange of parts and pallets without having any type of alarms come out throughout that process. So let's move on to the machining process and the monitoring of that process. So now we've got the parts on and off. We've got that interface with the automation. You're running your fixture, or you're running that part, you're machining that part, but now you want to make sure that during the process of that you're still within spec, you're still producing good quality parts. So we've got a couple options that we've got available to you. We got the vision-based broken tool detection, or it could be a contact-type broken tool detection. That's monitoring that tool, so when it comes out of the spindle, goes back into the tool magazine, we're going to check to make sure that it's not broke and it's still in good condition for the next part, and that feature was completely done. The other option that we've got is spindle load monitoring. So you can teach the machine on, as it monitors a spindle load, on what that load characteristic should be throughout the course of machining that part. So the benefit here is that you're monitoring that process. You're going to find out if you can maybe correct it before you start to produce reject parts, or you can look and make sure you're not damaging any of your tooling or something to the machine, and early detection of issues within that machining process. Now that you don't have the operator standing there day in and day out loading those parts, and now you've got that automation, you need to have something to make sure that you're monitoring that process. Let's talk about alarm notification and recovery. Yes, there will be alarms. There will be times when you'll need to recover the machine and or the automation. So with the machining center, we want to make sure that we've got a way to notify the people within your shop, whether it be a maintenance supervisor, your manufacturing engineer, area supervisor, that there is something going on with that cell. So we're able to remotely send messages via email, text, to let the service people or the other people within your shop that are supervising your shop operations that something is wrong with that machining center and or the automation. Along with that, so once you've corrected the alarm, you've identified it, you've got it corrected, now you want to get that system back up online safely and without any type of errors during that process. So we developed some safe program restart routines, which allows you to bring that machine back online safely so that it coexists with the automation. It knows what the automation's doing, and you're able to bring your machine back up online. You don't have to have your operator searching through the program for a particular tool or particular spot in the program in order to restart. So we're safely able to restart that program. So the benefit here would be the reduction of machine downtime because you're getting the information to the people who can help correct it and get the machine and the system back up and running as quickly as possible. And you're reducing the opportunity for errors during the recovery, during potentially operator error or something that may go astray during the recovery of that alarm and that machining center. Now let's talk about connectivity. So one of the things that we're seeing over the past couple years with our automated systems and our machining centers is it's becoming much more connected within the manufacturing environment. We're seeing more connections up with manufacturing execution systems, production collection, production information, data collection systems. And so the connectivity is becoming much more important when you're talking about these automation systems and automating that machining center. One of the things may be confirmation of a production release. So you want to make sure that either these batch of parts, when they show up in an automated cell and are getting ready to be run, you want to make sure that they've been completed upstream, that the process has been completed upstream maybe, or that you've approved the process, that the machining programs have been approved and been tried. The tooling has been approved. So the process has been approved and you're able to run that batch of parts across that machining center. So one thing is we are able to communicate with the manufacturing execution systems. The other thing is process management. So now that we've released that production batch in order to be run across the machining center, we want to make sure that the approved and only those approved NC programs are downloaded into the machine. The tooling information, the work offset information is also transferred down that machining center to get that machining center ready to run that batch of parts or that particular part type. Now, once you're running, we want to look at providing feedback as far as how that process is going. I talked about it with the machine options, but now from a systemic perspective, we're able to feed that information out of the machine tool back into the cell control system or up into the manufacturing execution system. And that information can include process information, your machine utilization numbers, performance information, the status of that machine, and also the status of your tooling. And the automation features to go along with that is your automation needs to be able to support that connectivity and make sure that it supports the communication between the machine, the manufacturing executions, whatever systems that you may have within your facility, and the cell controller. So the benefit here is you get real-time production control. You get control of what's going on within your production floor, within the machining process, and then monitoring and reporting back so you get real-time feedback as far as how your floor is operating, how that machining center is operating. So let's talk about the machining process and the work holding. These two go hand in hand with one another, so I'm going to talk about them together. First, talking about the machining process, you want your process to be stable. As with the machine, in order to give you a reliable machine, you want your machining process to be just as reliable or stable. You want to be where number 2 is high accuracy, high repeatability. As you continue to run parts automatically through that machining center, you want to produce consistent quality parts coming off that machining center. So you want your machining process to be repeatable. And then in order to monitor that, to make sure that you're staying within the boundaries that have been set up for your process, one of the things that we talk about is inspection cycles. So many of the cell control systems, and I'll get a little bit in a more detail about that a little later, but setting up a frequency of inspection. So you want to maybe inspect every 30th part or every 40th part or every part, or a certain feature needs to be inspected 100% of the time. You want to make sure that you've got the capabilities in order to set that up in order so you can monitor in the inspection processes. So the benefit, improved OEE, because now your machine may be running, but now you're running good parts. It's guaranteeing that you're running good parts and not scrap parts or questionable parts. So you're going to not only optimize, increase your utilization of the machine, but it's about the OEE and you're producing good parts. A little bit more about the inspection process and the integration of that into the automation. We've integrated several different types of inspection systems within our automated systems, CMMs, different types of hard gauging systems where we may be inspecting one or two features at 100% frequency. You want to determine what that frequency is that you're going to go through this inspection process. And then you want to make sure that any of those stations that you're going to integrate with the automation are able to communicate and interact with the automation system. So CMMs, we've integrated CMMs with robotic loading of the CMMs. But you just want to make sure you can communicate, number one, and then that you have access and you have the proper setup in order to support an automated feeding of parts through your inspection processes. So some of the features having to do that can be integrated into the automation would be process feedback to the machining center. And a couple different things to look at. Do you want to automatically feed process adjustments back into the machining center through work offsets, tool offsets? So you're taking those parts, you're running to the CMM, you're getting that data, and then you can look at packages and compensation software that would take a look at the inspection data that you're getting back and then provide offsets to the machine, directly to the machine, either automatically or maybe you want to manually approve those before they get adjusted on the machining center. The other one would be machine inhibit. So if you detect you've got a bad part, I've taken a part off of machine number 3 in the cell, and I put it in the CMM, and I got this feature that's out. Can you stop that machine? And we've got search systems where we stop that machine to make sure that we're not producing any more parts until an operator can intervene and look at the gauge report and find out, okay, can I continue on? Was there something that's just a flyer? And then we continue machining parts, or maybe I need to change a tool or a work offset. And then the management of your reject parts. So you will be producing when a part comes off the machine. If it's not within spec, if it's not completely machined, we classify that as a rejected part. So you want to have a way to quarantine them. Maybe you want to maybe put them in a lock box of some type. We've dealt with various different types of systems where a reject chute, or just putting the parts into a reject chute that's then collected by the operator, or maybe into, as I mentioned, a lock box where you want to have limited access to those rejected parts and you want to control what's going on with that. So the benefit here is that you're going to reduce your scrap potentially as you look at the inspection frequency and you're checking the parts, and you're going to quarantine out-of-spec parts so they don't go down the line. They're not going on to the next process that have been rejected out of the machining process. Work holding features. So let's talk about the fixture control. And this typically has to do with just part automation, where we're loading a part into a fixture that's resident on the machine. This particular, you see in the picture that we have here, that we have a rotary union attached to the top of the tombstone, and this is where we get the hydraulic and pneumatic connections from the fixture hydraulic unit into the tombstone and into the fixture for the control of that fixture. Looking at the clamp conformation, so whether the part's clamped or not, or unclamped, the fixture's clamped or unclamped. We've got a couple different ways that we're able to do that. By far the most common way is through clamp pressure sensing. So we've got pressure sensors. We detect that the clamps have reached a preset pressure setting. Once they reach that pressure setting, then we know that the part is clamped in the fixture. Same with the unclamps and sequence. We have pressure sensors on the unclamp side, so we know that when we reach our unclamp pressure, that the fixture is unclamped. Another way to do that would be through position sensors. We've implemented this before with a gap it's basically a gap sensor. So you got the receiver on the fixture, and you got the transmitter on the fixture, the receiver on the pallet. And so we put switches in the fixture, and so we detect where that clamp arm is at and make sure it is out of the way in the unclamp sequence before we unload and load the next part. And we can make sure that the clamp is fully engaged with the part. And the last one is broken pin detection. If you've got a rounded diamond pin that you're locating your parts over, or some type of locating feature, we can check to make sure that pin has not been broken sometime during the process of exchanging parts with that fixture. Part placement confirmation, talked a little bit about this before on the machine side, machine option. We want to make sure, though, within that fixture that you've got a means to detect that that part is properly located within that fixture prior to machining. And we have in our locating pads air seat detect, so we know that that part is located up against that particular locating pad before we start the machining process. And then there's part retention. Difficult to see in the fixture here, but up top there's a roller detent, and the bottom there's a roller detent. And what this allows us to do is to load that part into the fixture with the robot. Then the robot is able to go away and then start servicing the next machine in the cell if there's multiple machines in the cell. And that retention holds that part in place. And so now your robot doesn't have to hold it, where you can sometimes get conflicts between where the robot wants the part to go and where the fixture wants the part to go. So you want the fixture and to be able to take that part to put it in the final location that's required in order to start your machining process. And then chip setting. So we've got, you must keep that fixture clean, as I talked about before. And so with our through fixture hydraulics and our rotary union, we've got a coolant port that we could do through fixture coolant. So we show nozzles located, each one of the locating pads in this particular fixture. So we're flushing coolant when we're taking the part off and putting the new next part on. We're continuing to flush that part surface and the locating pads to make sure that that part and that locating pad are clean before we're going to clamp that part into place. And another thing to note is that when we do these style of systems, and you can see you do not see any piping, no steel lines, hydraulic, air, or coolant lines. All that is internal to the tombstone. So we'll gun drill the tombstone, put all internal piping within the tombstone so that there's no place for the chips to collect around those hydraulic or pneumatic lines. And then you want to design your fixture for maximum chip sheds. You want slope surfaces. You want to make sure you minimize any place in that fixture where chips can build up, because once again, you don't have that operator there to blow that fixture off when they're exchanging parts. So the benefit here is you're going to prevent part load failure. So you're going to be consistent. You're going to be reliable as far as exchanging parts on that fixture. And then with our rotary union connection up top, you got a very flexible fixture control where you can set up different fixture sequences and even controlling the fixture while it's inside the machining work zone. So let's talk about cell control systems. This is the heart of the automation. This is the brains as far as what makes the automation work. I'm going to divide this into two basic areas: pallet automation and park automation. And with pallet automation, the scheduling of the production through your cell is very important. So you got to determine what is going to be the priority as far as scheduling the production through the cell. Now, do I want to get maximum utilization of my machines? Do I want to make sure I meet my production order due dates that may be associated with an order? So within the cell control system, we're able to select between a couple different criteria what is the priority as far as how the cell controller schedules the cell. The next is monitoring the availability of resources. Are the fixtures available? Does the machine have the proper tooling? And is the machine ready, and is it ready and up online? So the cell controller will check and make sure that that part can be machined on that machine before it will take that and send that pallet or fixture with that part to that machining center. And then you would think about how you set up your scheduling. Do you need dynamic scheduling where you're talking about, I'm going to change the flow of pallets based off my machine utilization? So I'm going to change based off of if I've got a particular fixture that cannot be run because I just had a tool life out on that machine, so I'm not going to send that fixture to that machine, and do I send another fixture? Or do you set it up, maybe my order due date for that particular fixture is very critical, and so I want to force an operator or my tooling person in order to change that tool out, get that machine back up online. So you're going to go ahead and send that fixture to that machine, and you're going to have that machine flag an alarm and notify somebody that something needs to be done in order to run this particular part. Resource management, as I talked about, make sure that you've got the proper resources available as far as the tooling, and then the NC programs and the work offsets are then managed by your cell control system and downloaded to the machine based off the part type that has been loaded into the machining center. And then from an operational perspective, all right, what can your cell controller do for you to manage the operation of your system? We can provide work instructions. So at the operator work setting station, we can show them how they need to load a part. If you need to use a particular torque wrench for the torque setting, or a sequence of how you engage the clamps, we can provide instructions right there at the work set for the operator in order to tell them how they need to load that part. And then reporting of system performance, we've talked about this already, reporting out how that system is running, maybe where your bottlenecks are, if you've got a vehicle issue or you've got a fixture issue, something of that nature. And then communication with your manufacturing systems. Once again, that connectivity is becoming very important. So the benefit, a single point of cell control and status, this is where you can control your complete cell, and you're going to be able to determine what the status of that cell is. Then let's talk about the part automation. So with this cell control, a little bit different. You're running not very many different part types through, so you're typically running the same style of part through the machining center. And so you want to here focus on the recovery of the automation, and the auxiliary operation may be going on because your scheduling is not as important. So we want to have a place where we can go similar to the other cell control system, where we can see what the status of the cell is, what the robot's doing, what each one of the machining centers is doing, and then any of the auxiliary equipment. And then the control of those auxiliary operations. So if we're integrating part marking or part wash or deburr, something of that nature, we've been able to incorporate that into the control of those operations into our cell controller design. But as I mentioned, cell recovery. So it's important to be able to bring this system back up online very quickly and very safely. So we've developed one-touch, what we call single-touch robot recovery routines, or rehome routines. So if the robot gets into a position where it cannot continue on from that particular state, you're able to select this rehome routine. It'll bring the robot back to a home spot, and you're able to reset the cell. Wanting to keep that teach pendant out of your operator or maintenance guy's hands, you don't have to call a maintenance guy to recover it. So try and keep that teach pendant locked away in a box so you don't have to use it. And then along with that, we've developed cell run-out routines. So if you've got multiple operations on a fixture, op 10 and op 20, and you want to run that fixture out, or you want to run that cell out, you can select that through our cell controller. It will take the 10 off, the finished 10, put it on the 20, but it will not load the op 10. And it will cycle all those parts through until the machine is empty, and then it'll take the machine offline. Or if you want to change a part type and you want to run the cell out, all that can be done via the cell controller, where the operator does not have to go into the cell and manually pull those parts out. That's all done automatically for them. Once again, trying to keep that cell up and running and removing all those type of conditions and scenarios where the alarms and error conditions can happen. And then part status, as I mentioned, we want to be able to track the status of the part through the cells. So the cell controller tracks the status of the part as it goes through the different operations, the machining center, any of the auxiliary operations. We incorporate gauge cycle counters so that you can then determine when you want to gauge a part off a machine. And then the rejected parts, we handle those. Also, as I mentioned, in similar ways, I mentioned the fact that we can take them to a reject chute, a lockbox, or something of that nature. But typically, any part that has not been completely machined on a machining center, we're going to take that off and put it into a reject location. And the benefit from that, once again, is a single point cell control and the status of what's going on within that cell. You've got a single point where you can go to and find out what is happening within your automated cell. So finally, the last one, expert support resources. And so what this is here, what we're talking about is that you need several different disciplines to make a successful automation system, to implement a successful machine tending automation. So obviously the first one is automation. You got to have the experts or the people that are knowledgeable about how to set up machine tending automation. But remember, you also need to have those process application engineers to work with in order to get the fixture set up properly, that machining process set up in order to work nicely with your automation and the machining center operation. You want those options available to you, so you maybe need some engineering support from the machining center group. And then the systems interconnectivity. Here at Makino, we've got a very strong automation or system support group that is able to work with you to make sure your machining center automation is connected within your particular plant and environment, to make sure that everything communicates together. But it's not only Makino. Makino is able to bring all these resources to you in a complete package. But one thing you should consider is that you need some of these resources within your manufacturing facility. So automation, you want to have engineers that understand the automation, that can maybe improve upon the automation, that can recover the automation, along with your process and application guys, so they understand what the requirements are of automation, because we want you to be able to continuously improve this. We're going to give you that base system. We're going to get you started in this area, and we're going to give you a system that can run reliably, that can function over time. But you're going to have those people that can help improve that, because once you learn how to operate this system and you understand how it integrates with your other operations, you're going to find things that you're going to be able to improve upon. We'll be here to help you, but hopefully you're able to do some of that on your own, because that what is the real measurement of a successful machine tending automation. So continuous improvement and quick recovery of your automation systems. So real quick, a couple basic types of automation solutions. You may have kind of caught on to this throughout the course of going through the elements of a successful automation system: pallet-based automation and then part-based automation. Right? They have two unique set of features and typical applications that they're centered around. For pallet-based, the application is high to medium mix of parts. Your volumes are lower, maybe a medium size or low sized batch of parts that are run, but you got frequent changeovers between the different part types on a machining center. And understand that your buffer, your unattended machining operation, is coming from the pallets and the fixtures that you have set. So you set pallets, you set the work up on a fixture, and then you store it up into the storage location, and then the vehicle takes it to the machine when it becomes available. And in this scenario, the fixtures are typically manually loaded. We've seen customers moving more towards automating that process, hydraulically controlled fixtures, but for the most part, we see them being manually actuated when the parts are loaded into the system. And I'll go through the different system options, whether it's a larger machine pallet automated system, a system that's moving smaller pallets, fixture plate, or single machine pallet pull systems. So the machine pallet systems, this is where we're moving the machining center pallets. So we're on one series, whether it's an A51, A61, we're moving that pallet, that complete pallet, throughout the system. And the system consists of the machining centers, work setting stations, pallet storage, and our cell control system. But the benefits of this style, obviously, the first one is you're able to manage multiple machines from a central location. So at the work setting station, you got one operator that's servicing those fixtures. That's going to be going across multiple machining centers within that system. But also, you get the full capacity of the pallet. And what I mean by that is that you can have on top of that pallet any type of fixture. You can have a tombstone that's loaded on all four sides. You can have a single part setup. You can have multiple types of vices on that particular tombstone. So you got a lot of flexibility there when it comes to handling that machining center pallet. The next type I want to talk about is small pallet fixture plate systems. This is where we're transporting a fixture plate or a small pallet between machining centers, but there's some type of chucking system, such as an Aroa, a shunt, a System 3R chucking system that is within the machining center. And that's what the chuck, or what the pallet or the fixture plate is chucked to or fastened to when it's loaded into the machine. Once again, single or multiple machines, work setting stations associated with this, the pallet fixture storage, but we're still using a cell controller typically. On the smaller cells made with a single machine, we're only using the machine control in order to control the flow of pallets in and out of the machining center. So the benefits here, once again, multiple machines from a central location. As you can see here in the lower right-hand corner, we've got 3 DA300 machining centers being serviced by this particular automation, and the work setting stations are at the end. But what we're able to do with this style is typically integration of different machining platforms. You can see in the upper left-hand corner, we've got an EDM and then a milling machine on the other side. Down here, we got just DA300 machines with our what we call our MMCR product, but we've got systems that have got a V56i and A61 NX machining center in the same cell. So you can mix vertical and horizontal along with EDM machines within the same system. And then you're able to do different sizes. So you can have a 51, a 61, or maybe an 81 and a 61 in the same cell. And then also the integration of auxiliary equipment. You can see here we've got, in this particular system, a CMM, an inspection station, and a pallet wash integrated into the same cell. And we're able to do that fairly easily because we've got the same chucking system within that pallet wash and within that CMM inspection station. And then the machine pallet pool systems, tightly integrated with the machine control, attached to the machine. The pallet pool storage is right there, typically limited in the number of pallets, but it's a simple entry into machining center automation and simple pallet scheduling software. So let's talk about the part handling systems. The application parameters around that is where we've got few part types, but you got higher volumes, medium to high volume. You're not changing over that machining center between different part types very often. System features include dedicated machining resources. So now I'm dedicating a machining center to a particular part type or a class or a family of parts. The buffer system is through the parts, not through the fixtures. You're loading parts into the fixture. The fixtures are resident on the machining center. So you're getting that buffer from the parts that you're stacking up in front of in front of that robot automation. And then, of course, you have to integrate automatically controlled fixtures, hydraulic or air, something of that nature. So a couple different types I'll talk about here: standard part automation, and then more customized. So standard part automation, small part batches, single machine, typically only attached to a single machine. You got smaller part sizes and weights that are associated with that, so you're not going to integrate a system that's got a larger part type. So the benefits here: low cost part automation. So it's an easy way to get into understanding how that automation process works and some of the things around automating a process. A lot of these systems have simple setup and easy to go between different part types. So some of them are better than others. Some of them are walk you through the steps as far as to set the system up, and then very little teaching of points. Basically, the only points you have to teach are inside the machine. And they can be cobot-based or regular style of robot-based. And then we've got our customized part automation. It can be single machine, can be multiple machines, but basically high volume applications with limited part types. You've got multiple machines dedicated to those particular part types typically, and along with this, what we see a lot of times is the integration of those auxiliary operations that go along with machining of a part, such as marking the part. You might want to inspect the parts we talked about, wash the part, and then maybe even debur the part. So the benefits here: unattended machining times through the buffered parts. So maybe your buffer is a little less expensive because you're not having to do a whole bunch of fixtures in order to buffer those parts and get your unattended machining operation. Production of operator requirements. A lot of times we're seeing customers that just deliver the totes or the pallets or something into the cell, and the robot automatically pulls the parts directly out of the part bins. And then you're optimizing your systems around the part production requirements. You're customizing it around getting those parts through here at the most efficient manner. So after the presentation, we'll have a live Q&A session. Please stand by, and we'll answer your questions directly. Okay, looks like we may have ended a little bit soon, but I want to thank you for joining today. We have had a couple questions come in regarding the automating of machining centers. One of the questions has to do with can a pallet automation system be used in a high volume, low mix application? Which yes, it can. You got to look at the parameters around it as far as the cycle time requirements that your length of machining time. But the nice thing about it is that if you were to implement a pallet automation, a lot of these systems are standardized. And so you're not getting a lot of customization, not having to do a lot of customization to those style of systems. But still, your buffer, as I mentioned, is within the pallet and not necessarily just the parts. And then you're still typically manually loading those parts in the fixture, so you're not completely eliminating the operator from the process. But yes, very, very capable to run the higher volume, lower mix applications through pallet automation.
Another question has to do with the implementation of cobots. Is there any differences between using a standard robot versus a collaborative robot? And one of the biggest things that we see as far as that integration, obviously your robot interface is pretty much the same, but it has to do with now protecting some of the operations that are occurring with the machine, such as the doors, the access doors open and closing, and maybe the clamping of the fixture. With a cobot, you sometimes you don't have to have those safety sensors around the automation or the safety fencing around the automation because you do have the collaborative operation or the collaborative mode of the robot, which doesn't require safety sensors. But now then you have to protect some of the operations on the machine. So you need to be aware of that particular situation. So once again, thank you for joining today, and I hope you have a great rest of your day.